We were yesterday dealing with, as you know, simple harmonic motion, right? Yeah.
Yes, sir.
So with further simple harmonic motion today, this is the first class of the day for me in a way. Morning was occupied. So let's get started right away. Fine, dear?
Yes, sir.
Okay. In simple harmonic motion, last we saw was an equation. X is equal to A, sine of the angle omega t plus phi. And we had nomenclature for the terms A, omega, and phi done already, correct?
Yes, sir.
Okay. Now, X is the displacement from mean position, and you're aware of what do I mean by mean position.
Good
Mean
evening, sir.
position is a position where net force acting
Zero.
on the particle is zero, correct?
Yes, sir.
And you can let the particle rotate, let's say a particle taken, which I want to rotate, which I want to let go a circular track. If the particle is negotiating a circular track, then shadow of that particle on x or y axis will read exactly whatever we have discussed yesterday. What did I say? I told you yesterday about omega being related to angular speed. We call over here this omega, which I have made you write yesterday. We call over here this omega angular frequency. Please write it down somewhere. It is
Yes.
called angular frequency. I've asked you already, so it must be there with you. Anyway,
Yes,
just a
sir.
repeat. It's called angular frequency. And what exactly its unit being? Radian per second. Is it okay?
Okay,
What
yes, sir.
is it? Radian per second. So you're talking of angular speed along with angular frequency. Now, this is something which you should be very careful about. Now, why did I relate it with angular speed? Why I'm relating it with radian per second? What is the umbilical cord between angular frequency and angular speed? This you can very well establish by letting a particle negotiate circle of certain radius. Is it okay? What did I say? By letting a particle negotiate a circle of certain radius and then look for the shadow of this particle on x or y axis. I repeat, and then look for shadow of this particle on x or y axis. So let me show the same to you. What I'll do is position a particle extreme on x-axis. I'll position a particle extreme on x-axis, and then I'll make this particle rotate or negotiate the circle in anti-clockwise sense. Got it, yeah?
Yes, sir.
Okay, so this is the circle I'm in reference. These are the axes to me. X-axis being taken as the horizontal, and this is the position of particle at t equal to 0. This is the position of particle at t equal to 0. After some time, if the particle is rotating with angular speed omega, and omega, as I have said, the sense being anti-clockwise, right? Yeah.
Yes, sir.
So this particle will always traverse some angle, and the angle being marked omega t here. Fine. Omega, you know, is radian per
Yes, sir. Yeah.
second multiplied with t will get you radians, right? Yeah.
Yes, sir.
So what is this to me? This is angular speed multiplied with time to get me angle. Where the particle is, then at t equal to t over here, agreed? This will be position of particle at t equal to t. Agreement, Krish?
Yes, sir. Yes, sir.
So this is the position of particle at t equal to t. What you now look at is its shadow. Shadow on x or y axis. We wish get shadow of it on x or y axis. By that what I mean? I mean either this or this. Getting it, yeah?
Yes, sir.
Okay. Now as the particle moves from this position to this position to this position, if we are with blinkers and looking only for movement of shadow on x-axis, are you getting it?
Yes, sir.
Particle is, as you know, negotiating a circle, and circle is in a plane to be shown. But what I am reducing this to, study of particles shadow, right, dear?
Yes, sir.
So as the particle is negotiating in actual the circle, shadow of particle will move from where to where is very much apparent. Apparent
Yeah,
or
yes.
not?
Yes,
It's
sir.
very much apparent,
So
Veda.
up and down.
How will the shadow move?
So up
Shadow
and down. So up and down.
position. When particle is over here, shadow will be over here. When particle here, shadow here. Then particle comes over here, shadow here. Are you getting it?
Yes,
Yes, sir.
sir.
If we blinkers, we are only to look at the shadow of particle. Then can we say that shadow of this particle, which is negotiating circle with angular speed omega, is executing a simple harmonic motion? Shadow
Yes, sir.
of particle,
Yeah.
which
Yes,
is
sir.
moving with angular speed. Please be very mindful of the word uses here. Shadow of particle moving with angular speed omega, right?
Yes, sir.
Moving with angular speed omega on x, or for that matter even on y axis, is a manifestation of simple harmonic motion.
Yes, sir.
Manifestation of simple harmonic motion. Please see for yourself. Write what will be x over here. I need x. What will you write x equal to? Think about it. This is r to you, radius of circle concerned, correct?
Yes, sir.
Yes, sir.
So shadow length will be nothing but r
So
cos
R
of the
cos
angle
theta.
omega t. Radius.
Oh yeah.
Yeah, yes,
Yes,
sir.
sir.
Cos of the angle omega t, which can also be marked as r sine of the angle omega t plus pi by 2, right? Yeah.
Yes, sir.
So is it not
Yes.
akin to simple harmonic motion with phi being 90 pi by 2 and
Yes.
omega, which we then call, by then I mean yesterday, right? Yeah.
Yes, sir.
Omega, which we then call angular frequency, can you recollect?
Yes, sir.
Is nothing but over here gotten from angular speed, right? Yeah.
Yes, sir.
So there is an umbilical cord between angular frequency and angular speed. And that is what we did establish here. Got it?
Yes, sir.
Okay. Also from here we got to know that if a particle is executing simple harmonic motion about x is equal to 0 and it begins its journey from extreme, that means at t equal to 0, where is the particle? The particle is at x is equal to a. Got it, yeah?
Yes, sir.
Then we can get our equation, basic equation, which is x is equal to a sine of the angle omega t plus phi. Is this the basic equation, yeah?
Yes, sir.
And what you do, you place t equal to 0. So x is a, right? At t equal to 0, what is x? Tell me. It is
Yeah.
a again.
Yes, sir.
So a is equal to a sine of the angle phi is what you will be getting. Yes or
Okay.
no?
At t is equal to 0. Yes, sir.
You are t equal to 0 because it was given to you. See, mean position is x is equal to 0. But it is not mandatory for particle to begin its journey from mean position, right? When you
Yes, sir.
started recording is completely at your discretion, correct? Yeah.
Yes, sir.
You can start recording at the position where the particle was seeing its extreme or anyway. Mean position is not subject to when you started your reading. But your reading, you are free to take a call on, correct? Yeah.
Yes, sir.
So as you have free say on it, you took t equal to 0 when particle was at its extreme, fine?
Yes, sir.
And then you went ahead with basic equation because this is the only equation with us. This is the only equation with us on x. And x is equal to a for you when you started recording t equal to 0, correct?
Yes, sir.
When you started recording t is 0 and at that time you found x to record a, right dear?
Yes, sir.
So a is equal to a as usual, a is the amplitude and x is a here. And phi is then to take a value, one of the many values, pi by 2, correct?
Yes, sir.
So what we get x as is x is equal to a sine of the angle omega t plus pi by 2, right?
Yes, sir.
Which then can be simplified to a cos of the angle omega t. Find here
Yes, sir.
a cos of the angle omega t. And this is what I was highlighting, that if the particle begins its journey, either the particle is left from that position or you took your 0 for that position of particle. Got it, yeah?
Yes, sir.
Either the particle was released, for example, there is a spring, the spring was stretched, the particle was over here, mass was over here, and then what you do? You release it. So as you will release, mass leaves from which position here? Mass leaves from extreme position of its simple harmonic motion execution, right?
Yes, sir.
When you will release mass, how will the mass move? Mass will move to left, right?
Yeah. Yes, sir.
And then will come to a position where the spring is in zero deformation, correct?
Yes, sir.
So at that position, net force on mass will be zero as the spring is undeformed, right, dear?
Yeah.
So what will be x is equal to 0, mean position, getting it?
Yes, sir.
But will it stop there? Of course not. It will go beyond it, right?
Yeah. Yes, sir.
So you come to this position, and at this position again, momentary, it is to stop, right?
Yes, sir.
So extreme left and extreme right, it is to stop. And what will be extreme left distance? Same as extreme right. Can we say that?
Yes, sir.
So this particle or block was left from its extreme position, yes or no?
Yeah. Yes, sir.
We can start, if we so deem, we can start with our basic equation. This being the basic, no doubt about it. So we can start with our basic equation, but it will boil down to x is equal to a cos of the angle omega t, right? Yeah.
Yeah. Yes, sir.
For which case, for which case, for the
The first.
case when particle begins its journey from extreme position. Got it? Yeah.
Yes, sir.
Okay, so it's a customary that we begin with x is equal to a cos of the angle omega t if particle was seen at t equal to 0 and x is equal to a, right? Yeah.
Yeah. So one small doubt. So
Yes,
in
please.
simple words, what would you like very crude in a crude way, sir? How would you
Uh-huh.
differentiate between angular speed and angular frequency?
The angular speed and angular frequency, as such, if someone is just to ask you that is
Yes.
there a relation between the two, then you want to relate it keeping in mind, Krish, that you are looking only for the shadow length. You are not looking at the motion per se. So angular speed to relate to omega t or angular frequency, if you want to establish a relation, then you have to forego the planar motion of body. And
Yes.
angular speed is defined for planar motion of body, right? Yeah.
Yes, sir.
So it is divorce of logic to relate planar motion with linear motion. Getting it?
Yes, sir. Yes, I understood.
So it's not that you are relating. What I was trying to suggest is, are they distinct or there is some umbilical cord? Certainly there is.
Yeah.
So
Yes,
if
sir.
used to represent a motion which is in plane by its shadow, then angular speed features, and it is no more read as angular speed, because for angular speed you need to get the unit radian per second, correct?
Yes, sir.
So here there is even no remote relation with radian per second of angular frequency. What is angular frequency? Angular frequency is written as 2 pi f.
Yes,
Angular
sir.
frequency is related to f. F is in hertz, you know, frequency.
Yes, sir.
Angular frequency is per second, right? Yeah.
Yeah.
So
Yes.
this is hertz per second, and this is angular frequency. So how is angular frequency related to theta? There is no relation as such. It doesn't relate with theta. What it relates to? It relates to f.
Yes, sir.
Are you getting clear? And this is
Yes.
what is being called. Of course, we study about time period. Your question being slightly ahead on timing, but I'm making it understand to you. We find time period, and time period of oscillation will be 2 pi by omega, which we will prove in few seconds from now. Fine, Krish?
Yes, sir.
And then we will define what is omega from there. As you can see here, omega will be what to us? 2 pi by capital T, right?
Okay. Yes, sir. So 2 pi f.
1 pi T is nothing but frequency, right, Krish?
Yes, sir. Yes, sir.
So here that relation is nothing to do with angular speed, right here?
Yes, sir.
But there is something, some element, some reminiscence of it which we cannot discount on. So I just wanted you to figure that relation. Got it?
Yes, sir.
Okay. Shall we further?
Yeah.
Yes,
Yes.
sir. Sir, I have a
Okay.
question. So,
Yeah. Yes, Vedant.
sir, is every question of I read of in the scope of JE syllabus?
No, not every question. Up to rotational mechanics, almost every question, barring coriolis force.
Yes, sir.
Okay, up to
And
rotational
so,
mechanics. Huh.
sir, there is a question of demonstration. So, do we need to solve those questions?
Read that. Which question is it?
So, demonstrate that in the case of a steady flow of an ideal fluid turns into Bernoulli's equation.
Yes, that is very much within the realm of syllabus. You are asked to establish Bernoulli's theorem.
So, proving.
Yeah.
Okay,
So
yes,
you
sir.
are asked, they are asking you for a streamlined motion. Can you prove Bernoulli's theorem?
Yes, I got.
Okay.
Yes.
Okay, fine. Shall we go ahead then with this equation? This is the basic equation for us. X is equal to a sine of the angle omega t plus phi. And just to consolidate, I ask you a question right now. A particle was seen. A particle was seen at x is equal to 0. A particle was seen at x is equal to 0, moving leftwards, moving leftwards at t equal to 0. A particle was seen at x is equal to 0, moving leftwards at t equal to 0. If A is the amplitude, write equation for simple harmonic motion execution. If A is the amplitude, write equation for simple harmonic motion execution. What will be equation for simple harmonic motion execution? Think about it. How will you go about any equation on simple harmonic motion? Remember, we are to begin with let x be, right?
Yes, sir.
So no exception here. You want to begin with it. You will say, let it be x is equal to a sine of the angle omega t plus phi, correct?
Yes, sir.
Okay. And then what you do in next step, you say at t equal to 0, x is equal to 0, right?
Yeah. Yes, sir.
So you write t equal to 0 over here and x is equal to 0. What you'll get phi as, tell me?
0. 0.
Phi will be 0. Therefore, you get an equation x is equal to a sine of the angle omega t, correct?
Yes, sir.
But as I have told you, and you are to adhere to it, phi is equal to 0 is one of the many solutions, correct? Yeah.
Yes, sir.
General solution will not be 0. If I'm asking you for general solution, what you ought to tell me on phi?
N pi. So it will be n pi.
Okay, so please be mindful of that fact. Why I'm asking you to be mindful of that fact is if you write x is equal to a sine omega t as your eventual equation, getting it here?
Yes, sir.
As
Yes.
your eventual equation, then you will be no different from a particle which was at x is equal to 0 and moving to right at t equal to 0, correct?
Yes, sir.
So how will you make that distinction? Because this equation, if I take x is equal to a sine of the angle omega t as the answer, which is what you are getting from here, then this equation suggests with advent in time, x will be positive. Agreed? Say me yes or no?
Yeah, yes,
With
Yes, sir.
advent in time, if you increase time, then this equation is to read x being positive. Say me yes or no?
yes, sir.
Yes, sir.
Which is contrary to the state in which you are. Which is contrary to the state in which you are. Because for you, the state being x should be negative with advent of time, right?
Yes,
Yeah.
sir.
As we are coming from particle moving leftwards, so for
Yes, sir.
us,
Yeah, correct.
x with increase in time should get us a negative value. Same here, remember not here?
Yes, sir. Yes, sir.
So let me unveil it, but in turns. It is not that I will go by blanket perception only for one value I am always to look. I am to go as per what the author has tended. Over here, 0 didn't cut ice. And why it didn't? Because this is just one of the solution, one of the many solutions, correct? Yeah.
Yes, sir.
Yes.
So which one will bode well? Which value of phi will bode well? 0 didn't cut ice. So which will augur well? Tell me, dear.
The
What
n
shall,
pi. N
what
pi.
shall I take?
The n pi.
N pi. So if I mark over here plus pi, will it work? Let us check it out. Right here, I'm
Yes, sir.
marking now plus pi because phi cannot be 0. So phi taken is pi. Is it okay?
Yes, sir.
Will it work? I think this will work, correct?
Yeah, yeah, yes, sir.
Because
It
if I'll increase time, I'll get something plus pi. And something plus pi, sine pi plus theta is negative, correct?
Yes, sir.
So this is getting well with our case. Therefore, this equation is what we'll be going ahead with. Got it, yeah?
Yes, sir.
There can be other way also of finding it. As it is mathematics, you will have many a way. The other way could have been, once you got x is equal to a sine of the angle omega t, find v. How will you find v? By differentiating, correct?
Yes, sir. Dx by dt.
So what you will get? A omega cos of the angle omega t, right?
Yeah, yes, sir.
Where were we to go with 0, we would have got a omega cos of the angle omega t, right? Yeah.
Yes, sir.
And with this I place t greater than 0, I get v positive again, correct?
Yes, sir.
And v in our case should have been negative, yes or no?
Yes, sir.
So again we will say with velocity also it was not to gel. So what it should have come along with is phi,
Right.
correct?
Yes, sir.
So whichever way you are to, please be mindful of the fact that you have to look at both the aspects. It's not only about position, it's also about velocity. I'm not saying that it is also about acceleration. Why? Because acceleration and position are dependent on each other, right? Yeah.
Yes, sir.
If you justify position, acceleration is being fixed. So it is not for me to look for position and acceleration both, but certainly we'll be looking for position and velocity. So when particle will repeat its position as well as velocity, then that time will be called time period of simple harmonic motion. Got it, yeah?
Yeah. So can you repeat when
Yes.
particle?
Yes. Yes, yeah. Yes, Fresh.
When particle?
When particle will repeat, when particle will repeat its position as well as velocity. When particle will repeat its position as well as velocity, the time taken to do so, the time taken to do so is called time period. The time taken to do so is called time period. Now, just to make you understand and get a flavor of the same, what I do, I take a particle which is executing simple harmonic motion. A particle which is executing simple harmonic motion, and very simply it begins from x is equal to 0. Therefore at t equal to 0, where is the particle here? And I'm taking the simplest of all. I'm assuming that the particle is moving to the right. Got it, yeah?
Yes, sir.
The particle moves to the right. After some time, negotiated distance a will come to rest. Agreed?
Yeah.
Will come to rest. Thereafter,
Yeah.
what has happened to particle? First, it moves this way, went up to this point, it stops, and then it'll start moving this way. Agreed?
Yes, sir.
Okay. It comes to t equal. It comes to x is equal to 0. It comes to x is equal to 0. So it repeats its position. Say me yes or no.
Yes, sir.
Will I take this time as time period? It
Yes, sir.
comes to x is equal to 0. Are you getting what I'm saying? Please be very careful. It comes to x is equal to 0. In what time? In some time t prime. In some time t prime it comes. It reclaims its position. Got it, yeah?
Yes, sir.
Yes, sir.
It reclaims its position. Can I say t prime is time period for this motion? For
No,
the
No,
sir.
sir.
periodic
No,
motion?
sir.
No.
Can I say t prime is time period for the periodic motion that it is into execution?
No, sir. It
No,
is
sir.
not.
So we cannot. Why so? Why did you negate?
So
Sir,
because the
because
velocity is not the same.
Because of velocity. Very good. At t equal to 0, position being same, no doubt about it. But at t equal to 0, this particle's velocity was directed to right. The particle's velocity, this particle's velocity was directed to right, right here at t equal to 0. And at
Yes,
t
sir.
equal to t prime, it is directed to left. Got it here?
Yes, sir.
yes, sir.
So, though position got a repeat, but has not got velocity. The position got repeated, but has not velocity. Agreed?
Yes,
Yes, sir.
sir.
So T prime certainly will not be called time period. Okay, no issue. Particle, will not stop here. Why? Because it gathers some momentum. It will carry its journey to the left. Correct? Yeah.
Yes,
Yes,
sir.
sir.
It will carry its journey to left, and then at x is equal to minus a. At x is equal to minus a, Again, for a moment, it will come to rest. Agreed?
Yes, sir.
Yes, sir.
Momentary, it is again to come to rest. Thereafter, how will it move? Thereafter,
Sir,
how will
right.
it move?
Right.
Can
To
we
the
say
right.
to the
Right.
right?
Yes, sir.
Okay.
Yes, sir.
It moves to the right and reclaim yet again. Comes to this position, but this time at t equal to t double prime, right? Yeah.
Yes, sir.
Yes,
Can
sir.
I call t double prime the time period?
Yes,
Yeah.
sir.
Yes, sir.
Yes. So t double prime can be called time period. Got it?
Yes, sir.
Yes, sir.
Okay. Now this motion will be exhibited by x is equal to a sine of the angle omega t.
Yes, sir.
Correct? Again, we'll start with basic and we'll boil down to this. X is equal to a sine of the angle omega t. 0 will go with this case. As phi is 0, we are good in asking. Correct? Yeah.
Yes, sir.
Yes, sir.
Now, any function, any mathematical function has a period. What is period of sine is known to all of you. If I'm just to ask what is period of sine theta, you will say period of sine theta is 2 pi, right?
Yes, sir.
Yes, sir.
Then I ask what is period of sine 2 theta. If I ask what is period of sine 2 theta, then remember whatever is the period of parent, whatever it is being multiplied with, you have to divide it by.
Yes, sir.
Okay? So 2 theta will have a time period of how much? 2 pi by 2. Is it okay?
Yes, sir.
Yes, sir.
Okay. What can you say about period of sine theta by 2?
The 2 theta. So sorry, 4 pi.
4 pi. Got it, yeah?
Yes, sir.
So what will be period of sine omega t?
2
2
pi by
pi
omega.
by omega. Correct? What will be period of sine omega t? 2 pi by omega. Got it, yeah?
Yes, sir.
And this is what is the time period of simple harmonic motion. Capital T. What will be capital T? 2 pi by omega. Am I clear on this one?
Yes, sir.
Capital T will be 2 pi by omega. Let me ask you a very logical question then. If I am to move from x is equal to 0 to x is equal to a, owing to symmetry, can I say time taken will be capital T by 4?
Yeah,
Agree
yes,
or
sir.
not?
Yeah.
Think about
Yes,
it.
sir. Yes, sir.
Because T by 4 forward, T by 4 backward, T by 4 to the left, T by 4 to the right will get us in total T, correct?
Yes. Yeah.
Yes, sir.
Go ahead with it. It being T by 4. Therefore, from 0 to A, this particle will ask for what time? Capital T by 4, where capital T is the time period, correct?
Yes, sir.
Yes, sir.
Can you tell me what time will it take to move from 0 to A by 2?
So T by 8. No,
Okay,
sorry.
0
Wait.
to A by
No, no,
2.
no, 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 no,
What
no,
is
no. Sorry. Oh, yeah.
0 to A by 2? Vedant is going with T by 8. Suresh, what say you?
So 1 second.
Okay. Pratyush, what say you? Do you subscribe to what Vedant has said?
Sir, within 2 minutes, I'm telling.
Okay, okay.
So it's not t by 8.
Okay. What can it be then?
Sir, I am solving that, but then it's for sure not t by 8, I guess.
Fine. So you are not subscribing to it being t by 8. No issue. You can solve. Fine. T by 8 could have been the case provided acceleration given to you being a constant mention. T by 8 would have been the case provided acceleration given to you was constant mention. I
Sir,
know you do as well. That acceleration is not constant, correct? Yeah.
says it 3.
Okay, I'll come to that. Acceleration certainly is not constant, right?
Yes.
Acceleration
Yes,
depends
sir.
on it. So we cannot divide it by half as acceleration depends on x. Then what equation we are to go with? I told you there is only one basic equation. And what is that? X is equal to a sine of the angle omega t plus phi. Okay? This is my
Yeah.
basic equation. And given to you t equal to 0, x 0. So it boils down to x is equal to a sine of the angle omega t, right? Yeah?
Yeah, yes, sir. Then
Okay.
next is a by 2.
Right? You want to find time when x is a by 2, right?
Yes, sir.
So what we do? We write x as a by 2 is equal to a sine of the angle omega t prime, let's say. Clear, dear?
Yes, sir. I not take it as omega t prime. I took it as omega t.
T prime, I'm not relating it with T prime here. Just any T, any other T. I wanted to write any T1. T1, okay?
Yeah,
I want to
okay.
find T1. My aim is to find T1, right? Yeah. That is
Yeah,
what the
yes,
question
Yes,
position
sir.
is. What is T1? Okay?
yes, sir.
Right, Krish?
So, yes, sir. T1 is 5 by 6 omega.
Yeah. So from here, half is equal to what do we get? Sine of the angle omega T1. And one of the solution, as you know, and rightly so, omega T1 will be how much to us? Pi by 6, right?
Yes, sir. 5 by 6.
0, 1 by 2 that way. General solution I'm not going with. I'm going with one of the many solutions, as you know. And that is good with me as that being the basic. So T1 is what to us? T1 is pi by 6 omega. But I have positioned the question at capital T. I didn't ask for T1. Isn't it? So what will
Yes.
it be in terms of capital T? Tell me. T1, what will it be in terms of capital T? Say from here, T by, what shall I
Yeah.
write? 12.
One
Shall
second.
I? Shall
Yeah.
I?
Yes, sir. Yes, sir. Yeah.
Yeah. So T1 will be what to us? T by 12. Please check this question, class. Very important. And another
So how
reason
it
to
came
coming
pi by
from this
6?
one. Yes,
So,
Vedant, you think
so
something?
how it came? So pi by 6, how it came?
This pi by 6 is because sine, if you write sine term here, sine 0, sine 15, sine 30, then the
Yeah.
values are
Oh,
known
yeah,
to
yeah,
us.
yeah. Got it, sir. Got it.
Okay?
Yes, sir.
So T1 is equal to capital T by 12 here, correct?
Yes, sir.
And what time then it will take to move from A by 2 to A? Anyone? Quickly, please. A by 2 to A, come on, that is brainer. That is non-starter. Come on, tell me. No brainer, non-starter. What will it take to move from
T by 6.
A by 2 to A?
The T by 6.
Yeah.
By 6, right? Yeah. T by 4
Yes,
minus
sir.
T by 12. That is to get you T by 6. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Sure.
Yes, sir.
Yes, sir.
So whatever being given to you, of course, they are not to ask you on T by 4. They will not ask you for quarter. They will ask you what time will it take to move 1/3, 1/4. They will not 1/3, half, whatever. You are good with this equation. I presume you are good with it. Correct?
Yes, sir.
Yes, sir.
Uh, Now let me get you a different level question. Write down. A particle was seen. A particle was seen at left extreme. A particle was seen at left extreme. Given t equal to 0. Given t equal to 0. Corresponding time. Given t equal to 0. Corresponding time. If particle takes t1 to move from A to C, if particle takes t1 to move from A to C and t2 to C to B and t2 to C to B, where B is the other extreme. Where B is the other extreme. So extremums being given to you. Is it okay, dear? A and B are extremums.
Yes, sir.
Yes, sir.
Now, find T1 to T2. Find T1 is to T2. Can you get it based on what you have from the last question garnered? Think about it. It's about application now. Left extreme to right extreme, it moves. This is in what ratio? I think I have told you 3:1, correct? Yeah?
No, sir.
Can I give you that?
No,
No,
sir.
sir.
Is to C is to C is to B. Distance wise being 3:1. Fine?
Yes, sir.
Think about it. It's not a good idea. Not much of calculation. 2 or 3 lines. That's it. As we are coming from a question, we have to take some cue from that question, the previous.
So 1/3 is to.
1/3, okay?
So 1/3 is to. No, so wait.
Shall we?
So
1 second.
Okay.
so it's 4:1, I guess. Not 3:1.
Okay, let's get solve this question. 4:1 is what I got. I'll get you just 1 point, and that'll lead to the answer. I'll get you just 1 point. And the point being, if A is left stream, B is right stream, then somewhere midway, as we know, will be the mean position.
Yes, sir.
Yes, sir.
This is the mean position. Getting it here?
Yes, sir.
Yes.
And if this is the mean position, then this part is amplitude to you.
Yes, sir.
3.
Getting it, yeah?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Amplitude to you, and accordingly, this part will also be amplitude to you, correct?
Yes, sir.
Yes, sir.
So, in a way, particle moves 1.5 of amplitude, correct?
Yes,
Yes,
sir.
sir.
Because the total is 4 and 3 being taken. So 1.5 of amplitude. 4 means what is 4 to relate to? 4 is to relate to twice of a, correct? Yeah.
Yes,
Yes,
sir.
sir.
So accordingly, you can say from A to C, what is the total time from A to
By
mean
4.
position T by 4 is known to you. And from
Yes,
mean
sir.
position to A by 2, just now you calculated T by 12, correct?
Yes, sir. Yes,
Sir.
sir.
And the rest, of course, is known to you T by 6. So what should
Yes.
have been the answer? T by 4 plus T by 12 divided by T by 6, right? Yeah.
Yes, sir.
Okay, so please be very careful of these questions. Not much, but they can gain you good 4 plus marks. Okay, let's move on to the other question. And the most important component of simple harmonic motion, which we will have to negotiate with, is spring mass system. Is it okay? So look
Yes, sir.
Yes.
for many a system. There are many a system, but we are to look for the system which holds more water, and that being certainly one of them being certainly spring mass system. Is it okay?
Yes, sir.
Okay, so let us take spring mass system and try to write for simple harmonic motion of the block connected to spring. Write down. Let us take a block of mass M. Let us take a block of mass M connected to a spring. Let us take a block of mass M connected to a spring of a spring constant K. Let us take a block of mass M connected to a spring of a spring constant K. Write equation for simple harmonic motion. Write equation for simple harmonic motion. Following force following force and energy method. Following force and energy method. Now I am to unfold another aspect of simple harmonic motion, which to some extent is to your delight, but at the same time to your plight. And the reason I'm saying so, being never seen a question organically on simple harmonic motion asked. Only on simple harmonic motion. It will be on simple harmonic motion, but it will have 2 or 3 concepts amalgamated in it, either with fluid or with rotational mechanics, with gravitation, whatever it may be. They will try to somehow amalgamate with other concept. And the reason for it being, any question which you get on simple harmonic motion, primarily on simple harmonic motion, we have 2 methodology to solve those questions. 2 methodology to solve those questions. One is, of course, the first method. We have been working on it for long now. And the other is energy method. So I will unveil the second one for you. Let us take a spring of spring constant K. Spring of spring constant K. There is a block which is nailed the spring with. Okay, find ya. So you have nailed the spring with a block of mass M. You displace this block, and when you displace this block, you give spring a deformation of X. As it got displaced by X, the spring gets deformed by X, right?
Yes, sir.
And block continues to move to the right. You have given it enough thrust. You have given the block thrust enough to continue to move to right with some speed v. Even after deformation of spring being x, block continues to move to right. It will stop but has not stopped as yet. Got it? Yeah.
Yes, sir.
Yes, sir.
Now let me write Newton's second law of motion. What will I write? Against it is minus of km. Kx is equal to m into a. Agreed?
Yes, sir.
Minus owing to the direction being opposite to acceleration. So minus of kx is equal to m into a. Correct?
Yes, sir.
Displacement to the
Yes,
right,
sir.
acceleration to the left. Agreed? Yeah.
Yes, sir.
Okay. So minus of kx is equal to what to us? M d square x by dt square. Newton's second law of motion.
Yeah.
What do we get from here? Minus of k by m, x is equal to d2x by dt square. Please recollect, yesterday I told you that omega is subject to system, right?
Yes, sir.
Yes, sir.
And yesterday we got, if you can flip and check, G by R, correct?
Yeah.
For the term G by R seen accompanying X, right? Yeah.
Yeah. Yes, sir.
Today what accompanies X is K by M, right?
Yes, sir. So
It
K
is
by M
for
is
this reason. It is for this reason that we take it as omega square so as to bring it to even keel. Is it okay? Just to bring it to even keel, what we do? We treat it with one term, omega square, where omega, I made a statement, is subject to system under study.
Yes, sir. So can
Yes,
we
sir.
take K by M is equal to G by R?
Yes, there it was under root of G by R. Here for spring mass system, what will be omega?
This one K under root of K by M.
The root of K by M. Please take good note of it. For spring mass system, omega will be under root of K by M. Okay, good enough. We got it by, as you can see, force methodology, correct?
Yes,
Yes, sir.
sir.
Now energy. Tell me what is energy kinetic to be associated with this system. You will say half m v square, agreed?
Yeah. Yes.
Unless
Yes,
stated,
sir.
we don't associate mass with spring. Remember this. Though I'll take mass with spring later, but to begin with, we don't associate mass with spring. So kinetic energy will be attributed only to mass, the block M, block with mass M, right there.
Yes, sir.
Yes,
So this
sir.
is kinetic energy of system. And what about potential energy? Potential over here means half kx square, right?
Oh, yes, sir. Yeah.
Potential doesn't mean gravitational potential energy. Got it? Yeah. That is not changing. You can see for yourself. And that is not a force which varies. So that force doesn't cut to us or doesn't merit to us, let's say. Okay, what will it change? I'll come to it. But for now, certainly we are not dealing with gravitational potential energy, right?
Yes, sir.
Okay. So this is what potential energy to us? Elastic potential energy. Got it?
Yes, sir.
Yes,
So
sir.
kinetic energy plus elastic potential energy. And as there is no friction, this should be a constant. This equation should be a constant. If you'll ask me why will it be a constant, I am to counter ask, or I'll point the question back to you asking which force can dissipate energy. Which is
There's
the
nothing else.
force here which may be attributed energy loss to? Spring is a conservative force, you know, correct? Yeah.
Yes,
Sir.
sir.
So there is no loss of energy. If there is no loss of energy, total energy must remain conserved, right?
Yes, sir.
Yes, sir.
That is what we have written. So total energy remains conserved and it is equated to C. What I am to do next is to differentiate it. what I am to do next, simply I am to differentiate it, but not before changing V. Let me change V first. Can we write V as dx by dt? Anyone having any confusion on that?
No,
No,
sir.
sir.
Okay, now we are to differentiate. Half m twice of dx by dt, d2x by dt square, plus of half k twice of x dx by dt is equal to 0, right?
Yes, sir.
Okay. dx by dt cannot be 0, cancelled, right dear?
Yeah.
Do we get the same relation as before? Do we get the same relation as before or not? Say me yes or no.
Yes, sir.
So yeah.
Okay. So it comes with two methodology. Either force or torque. As when we go in rotation, force will change to torque. You know that very well. Correct, yeah?
Yes, sir.
Yes, sir.
So force, torque, or energy method. Fine.
Yes, sir.
Yes, sir.
Okay, good enough. Now, yesterday we were dealing with an equation. I want to get back to that equation. That equation was on velocity dependence or speed dependence and dependence of speed with x. What that was to read, yesterday we saw v square is equal to omega a square minus x square. Omega square a square minus x square, right? Yeah.
Yes, sir.
If this is what we have as v square, multiplying equation with m by 2, what we get to see is half omega square a square x square is representation of kinetic energy, right?
Yes, sir.
So kinetic energy of a particle executing simple harmonic motion varies with x, taking this as the form, right? Getting it here?
Yes, sir. Yeah.
Varies with x, taking this as the form half m omega square a square minus x square. Got it?
Yes, sir.
Okay. And
Sir, can we?
total energy. Let me
Sir,
now ask you on. Fine, this is kinetic energy. Can you tell me what will be potential energy? Can you tell me what will be potential energy? The moment I ask you what will be potential energy, you are to rebuke. You are to rebuke asking me. You said once that potential energy relates to field, correct?
yes, sir.
Yes,
And
sir.
here, if you are asking me anything on potential energy, then the first question that you are duty bound to answer is what field is being tendered here? Which field against I am to calculate potential energy? So to save my skin, what I am to tell you, that assume spring force to be the field force. What it is?
Yes, sir.
Yes, sir.
I say assume spring force to be the field force. Got it?
Yes, sir. So one small doubt.
Yeah.
So if you take kinetic energy, half m omega square a square minus x square. So kinetic energy is equal to half I naught omega square, no sir. So can we equate
I
I
know
naught to m?
square is for which case there? For the case when you have I, when there is rotation.
Yes,
I'm
sir.
talking of block which is in translational motion.
Okay, yes, sir. Yeah.
Yeah, I will be coming to rotation. Don't worry, dear. Just hold your thoughts for now. Right here.
Yes, sir.
So
Yes,
half
sir.
m
Yes, sir.
square a square minus x square. Now I was talking of what is potential energy to be attributed to what field. I ask you to take a pseudo field and that field being spring force, correct?
Yes, sir.
You know spring force is conservative in nature, so it qualifies being understood. It qualifies being understood as a field force manifestation. Got it, dear?
Yes, sir.
And in that case, what is elastic potential energy with a spring associated? You have studied this in work energy power, right?
Yes, sir.
Yes,
Half
sir.
kx square, right, dear?
Yeah.
Yes, sir.
K here we know. What is K? I told you omega is equal to under root of K by M for a spring mass system, correct?
Yes, sir.
Yes, sir.
K will be what from here? Omega square M, right here?
Yes, sir.
And then multiplying it with x square, got it?
Yes, sir.
Yes,
What
sir.
we then end up getting is half m omega square x square. What is this to us? Potential energy. What potential? Elastic potential energy. Got it?
Yes, sir.
Yes, sir.
Course, of course, let me make no bones about it that I have taken over here a particular system, and that system being spring mass system, correct?
Yes, sir.
Yes,
But
sir.
I did try, which you can appreciate, I did try to do away with K and M both, thereby making my equation generic, correct? As I made good of the general notation omega, right, dear?
Yes, sir.
So I did absolve myself of going selective. The moment I change it to omega, now this applies to any system.
Yes, sir.
Idea. So this
Yes, sir.
applies to any system. For any system, we write kinetic energy as this. And this is the equation for potential energy. Got it, yeah?
Yes, sir.
Okay. Now make an observation and tell me something about total energy. Tell me something about total energy.
Half m omega square a square.
Yes, half m omega square a square, which is independent of x,
Yes, sir.
Yes,
which
sir.
is independent of x. So total energy is constant. Remember this term, please. We'll be using in waves as well. A particle which is executing simple harmonic motion. Total energy is constant. Of course, kinetic and potential will oscillate. Of course, kinetic and potential will oscillate. That means kinetic energy will change with time and will also change potential energy with time. I have
Yes.
shown you with x, but you know x in turns depends on time, correct? Yeah.
Yes,
Yes,
sir.
sir.
What is x equal to? X is equal to a sine of the angle omega t plus phi, correct?
Sir.
So x in turn depends on time. Therefore, kinetic energy and potential energy, they change with time. I'll come to their frequency later. Firstly, get me the plot of their variation. So plot for potential energy versus x and kinetic energy versus x, all of you. Please do the plot. Potential energy versus x, not time. Potential energy versus x and kinetic energy versus x.
So for the potential energy versus x will be a hyperbola.
Okay. Potential energy versus x will be a hyperbola. Agreed. It's a hyperbolic plot. What about kinetic energy versus x?
So kinetic energy versus x also will be a quadratic equation. Basically, it'll have a constant and with hyperbola.
This is for potential energy without doubt. This is a simple term. You can write it as y square is equal to 4ax, right? Yeah.
Yes, sir.
Potential energy. And if you look into it minutely, even kinetic energy is a parabolic function. Kinetic energy is also parabola, Krish, because kinetic energy is half m omega square a square minus x square. So this is a parabola which is being with opposite curvature and shifted upwards.
Yes, sir. And the y-intercept will be half m omega square a square, no, sir?
Wait here, yeah, that will be true because x is equal to 0, so that will be half m omega square a. This will be half m omega square a square. In fact, as we have taken it to that point, you can say that beyond this the particle cannot go because it will be energy forbidden zone. Are you getting it? This is the maximum. This is the maximum of potential energy and minimum of kinetic energy, right? Yeah.
Sir.
So maximum of potential energy and thereby minimum, which is 0 of kinetic energy. It cannot go beyond that range. For any position, what will be A plus B? A plus B. Can you tell me?
Half
This
m
is A
omega square.
and this is B. What will be A plus B for any position? Yes, Krish.
So half m omega square a square.
Yes, half m omega square A square, right? Yeah.
Yeah.
So energy is constant, and this is the plot that we are getting. Now, if x is given as a sine of the angle omega t, if it is, right?
Yes, sir.
If x is a sine of the angle omega t, then kinetic energy will be half m omega square a square minus a square sine square omega t, right?
Yes, sir.
Which is half m omega square a square outside. 1 minus sine square omega t cos square omega t, right?
Yes, sir.
Is it not oscillating? Is not kinetic energy oscillating? Say me yes or no.
Yes, sir.
Yes. And with what frequency? They ask this question in everyday kind of examination they do. Okay. What is the frequency relation between X and kinetic energy? X, you know,
Pi
time
by
period
omega.
is 2 pi by omega, correct?
Yes,
X
sir.
time period is 2 pi by omega. And kinetic energy time period will be pi by omega, correct?
Yeah. Yes, sir.
Square function. So pi by omega. Got it, dear?
Yeah. Yes,
So
sir.
as time period is known to you, so is frequency, correct?
Yes, sir.
1 by t, 1 by t is frequency. So omega by 2 pi for x. And 1 by t frequency. So omega by pi for kinetic energy. Got it, yeah?
So one thing. Yeah. 1 second.
Yeah.
Yes, sir. Yeah.
Got it? So we know
Yes.
how they are related to each other. Fine?
So omega by d pi. Is it d pi?
By pi. Only pi, na? 1
Okay.
by t.
Okay. Yes, sir.
This is time period. This is time
Yes, sir.
period.
Yes.
Okay? So that will be frequency. Can you clear air over frequency of potential energy? What will be the frequency of potential energy? Come on, it's not difficult.
Sir, this one. Same thing.
Yes.
Omega by pi. Omega by pi.
Pi, same as that of kinetic energy, right? Yeah. Here it
Yeah.
is
Yes, sir.
cos square, there will be sine square, correct?
Yeah. Yes, sir.
So that will be no exception to what you got for kinetic energy. Both are to be same on frequency. Yes, frequency of x is different, is half of them, correct?
Yes, sir.
Okay, good enough. Now, with this part being taken, we are literally coming to the closure on theory. but it has got team questions to be solved. SHM is a complete, I'll say, dud on theory, but questions are good on number in this. So let us take questions one after the other. As I'm in spring mass, I'll deal with spring mass questions first. Yes, dear, you're saying something.
Just 1 second, sir. I will note down one point. After that,
Yes, yes, sure. Sure.
yes, sir. I'm done.
Let us take two masses. Let us take two masses M1 and M2. Let us take two masses M1 and M2 connected by a spring of spring constant K. Let us take two masses M1 and M2 connected by a spring of spring constant K. Find time period. Find time period for simple harmonic motion exhibited by this system. Find time period for simple harmonic motion exhibited by this system. Now, let me tell you the mood, the very important point related to simple harmonic motion study. Whenever they ask you to find time period or anything related to simple harmonic motion, the first thing that you are to do is to disturb the system. Getting it, dear?
Yes, sir.
Yes,
The marble bowl case, remember or not?
Yes, sir.
So if you don't disturb it from its state of equilibrium, will it ever execute simple harmonic motion?
No. No, sir.
So what we are to do, we have been given a system, we'll have to disturb it. And after disturbing, we see for force equation or energy equation. Got it, yeah?
Yes, sir.
yes, sir.
Now, given to me is a mass M1 connected to a spring of spring constant K, and we introduce another mass connected to the other end of spring this time, M. Of course, spring is in its natural length, so there is no force. We disturb, we move M2 to right or M1 to left, whichever way you want to disturb, you want to nudge it, correct, dear?
Yes, sir.
So we shove it a little, and after of that, let it fend for itself. Now, if you have extended spring and let the system fend for itself, first question that I need to ask you is, will the system translate? System. I'm not asking you about M1 or M2. It goes without saying that M1 will move and will move M2, right? Yeah.
Yes, sir.
Yes, sir.
I am my question, and I am being asked on center of mass. My question is position on center of mass. I am being asked on center of mass. So tell me, will the center of mass of this system, two masses and a spring, get translatory motion? Will it get translatory motion? Yes or no?
Pull from both the ends.
I have pulled and then left. I have pulled.
Yes,
Your time starts from where I did release the system, not when I was pulling. Got it? Yeah.
Yes, sir. Yeah.
Okay. So from that time, when I have withdrawn my deforming force on a spring, how the motion is exhibited known to you. I'm just asking for, will center of mass move after of the force withdrawal?
Sir, I don't think so. It'll move.
Of course, it is not to move because center of mass movement is to be ascribed to external force, correct?
Yeah. Yes, sir.
Yes, sir.
Normal acting upward, mg acting downward, and they are, by the way, balanced as well. I'm not interested in y direction motion. I'm asking for x direction motion. Is there any external force acting on system in x direction? To which the answer will be no, external. The spring
Yes.
force is not external, correct? Yeah.
Yes, sir.
So, center of mass, first point, very important. And these are on which questions are being asked. Once was asked on this in IT. Center of mass, of course, will remain at rest, correct?
Yes, sir.
Yes, sir.
Now, L is the natural length of the spring. L is the natural length of the spring. Can you tell me where will be center of mass? Center of mass will be found by writing m2 into L plus m1 into 0 divided by m2 plus m1. Right here, can you recollect?
Yes, sir. Yeah.
Recollect, Vedant?
Yes,
We have
sir.
done this. Center of mass.
Yes,
So
sir.
this is what to us, this distance, this length will be, as we wrote, m2 into L divided by m2 plus m1. Fine.
Yes, sir.
And accordingly, what will be this to us? This one will be L minus this,
Yes, sir.
Yes,
and
sir.
that will give you m1 into L divided by m2 plus m1. Please do check, cross check. Cross check. Got it?
Yes, sir.
This one. Yeah?
Yes, sir.
So you got M2L, M2 plus M1, M1L, M2 plus M1. These are the length in a way as measured from center of mass, right?
Yes, sir.
Yes, sir.
And we can these are the length of two springs. If I'm looking from the prism of there being two springs, got it?
Yes,
If
sir.
I'm looking from the prism of there being two springs, then these springs are of what length? M2L divided by M1 plus M2 and M1L divided by M1 plus M2, right here?
Yes,
Yes,
sir.
sir.
And I can very well go with this impression that I have got two springs. As wherever I am, and I'm being at center of mass, from center of mass I see only one spring to the right, and this spring is of length M1L divided by M2 plus M1 for me, and I am at rest, correct? Yes or no?
So why not? Why not to the left?
You can take, no problem. You can take any side, Krish. Okay? You will do that by left side as well. Any side you can take. Equation eventual is to remain the same without doubt. Is it okay?
Okay. Yes, sir.
Okay, so I have taken to the right, and here the block in study, because to the right block is M2. Correct?
Yes, sir.
Okay. Now tell me. Or left. Fine. As Krish wanted to go to left. So this is the one. Okay, Krish? M2L divided by M2 plus M1. And what mass we are associating with it is M2. Fine?
Yes, sir.
Yes, sir.
So, can I, Swana, it's a question, well, can I say that we can go with left or right, keeping K of spring constant?
No.
Can I write my equation taking M2 as mass and K as spring constant if I am to write for left? Can I change it to one spring and one mass system? Is it possible? Of course, I am at center of mass. I see only one spring when I'm looking to one side. I cannot see the other one. So I am looking at only one side and one spring and a mass associated with it. Correct? Yeah.
Yes, sir.
So can I relate it to a spring mass system?
One second.
Can we relate it to a spring mass system? Spring constant K, yes or no? With
So,
spring constant K, yes, Krish.
so 1 second.
So I guess yes.
Okay. Pratyush, take a call.
Yes, sir.
Okay.
Spring constant.
Yeah, yes, sir. It will change.
Please remember, spring constant is subject to length. Spring constant is subject to length.
Yeah.
If you change length, then spring constant will change with it. If you change length, then spring constant will change with it.
Yes, sir. That's what I mean.
By this, what I mean, K into L or K multiplied with displacement always remains the same. The product remains the same. Is it okay?
Yes, sir.
So if L is to relate with K, then whatever will relate with the length that you have taken. What is the length now? Length is no more L, correct, dear?
Yes, sir.
Length is no more L. What is length? M2 into L divided by M2 plus M1. Say me yes or no?
Yes, sir.
Yes.
So what will be K here? L and L gone. K prime is M2 plus M1 whole into K divided by M2. It's a very important concept. Please remember, and about 75 to 77% students never get to know that K is function of L. You know K is inversely proportional to L. Can we say that?
Yes, sir.
Okay, so please
Yeah.
remember, K is inversely proportional to L. And having said that, now you can say, yes, we can go with M2, but K will change to K prime. Got it?
Yes, sir.
So what will be omega? Omega will be K prime by M2 whole under root.
Yeah, yes, sir.
Coming from the previous derivation of ours, correct? Yeah.
Yes, sir.
Yes, sir.
Yes.
K prime by M2. M2 was in picture over here. So K prime by M2 divided by, under root, correct?
Yes, sir.
So what we have taken over here, just a minute. M2, we took M2, right? And length was how much? Left, right length was?
M1L.
What was
No,
the
it is
left?
M. So it is M1, sir.
Left
So you
side
take
was
it both as
M2,
M.
right? This was M1 now, M1 now.
Yes, sir. You took both as M2.
M1, correct?
Yeah, yes, sir.
Okay. This will be M1, this was M1 and this was M2, correct? I wrote both as
Yeah.
M2, right? So this will change, right? This will be M1, correct?
M1.
So K prime is this to us. K prime is M2 plus M1 divided by M2. And there is already an M1 over here. So M1 K whole under root. Check there. There is a very important equation coming. Fine?
Yes, sir.
Check it. I'm not erasing any point. Fine?
Yeah.
Okay? So the term, this one, M1 plus M2 divided by M1 into M2. This is basically mu, where 1 by mu is 1 by M1 plus 1 by m2. What is this to us? Mu to us. Please do check. This is mu to us, where 1 by mu we write as 1 by k1 plus 1 by k2. So what will be mu from here? m1 into m2 divided by m1 plus m2. Agreed?
Yes, sir.
And if I want to use over here, we get it as k by mu under the root. Getting it?
Yes, sir.
K by mu whole under the root. Right there?
Yeah. Yeah. Yes, sir.
Omega is k by mu. Previously, when there was only one mass, we got it as k by m. Here there are two masses. We are getting it as k by mu, where mu is called reduced mass of system. What is mu called? Reduced mass of system. Write it down. Where mu is called reduced mass of system. And if you have taken the right one, Krish,
Yes, sir. You'll get the same.
K prime, again the same, nothing will
Yes, sir.
change.
Yes,
K
sir.
prime by M2, and K prime in that case will be M1 plus M2 divided by M1.
One. Yeah. Yes, sir.
Okay? You'll get the same. This also makes you realize that time period for both the blocks will remain same.
Yes, sir.
Time
Yes, sir.
period remains same. Masses being different, but time period will remain same. Amplitude will also be different, but time period will remain the same. Got it here?
Yes,
Yes,
sir.
sir.
Okay, so this is very important derivation, and this is very frequented. Very frequented in everyday kind of examination, though I'll say k by mu whole under the root. Very frequented as.
So for them to frame a question, in case if it's a numerical question, they'll give us this one. They tell that reduced mass is given as this, k is this, find omega.
Now they won't tell you reduced mass, they'll get you M1, M2.
Okay.
Won't tell you what is reduced mass. Reduced mass is our brainchild, correct? Yeah.
Yes, sir.
Okay. So from there, they will ask you what is time period. They can ask you what is amplitude. I will be coming to. We can easily calculate what will be amplitude. Well, how will I calculate amplitude here? How will I calculate? I know spring mass system right here. I'll come when it will stop. Correct?
Yes, sir.
Yes, sir.
We know spring mass system. Nudge. So I will get to know when will it stop, and accordingly we'll be able to calculate amplitude. Okay.
Yes, sir.
We'll take questions. We are taking questions here. Questions. We are to position 2 to 3 classes only on questions. Don't worry. Okay, write down. Next. Let me amalgamate concepts now. Shall we?
Yes, sir.
Yes, sir.
Okay, write down. Given two blocks of masses M1 and M2. Given two blocks of masses M1 and M2 connected with a spring constant K. Given two blocks of masses M1 and M2 connected with a spring constant K. Find amplitude. Find amplitude that is maximum displacement. That is maximum displacement if M1 is not to slip on M2. If M1 is not to slip on M2. This is M1, this is M1, this one is M1, and this is mu to us. Mu is given to you. And this being smooth, so mu is 0. spring of spring constant K given to it. You are to move this system, but keeping in mind they are to move as one unit. Got it, yeah?
Yes, sir.
Yes, sir.
M1 and M2 should not break from each other. There should not be any relative motion between M1 and M2. And what will be amplitude for the same? Either they can get you amplitude and ask mu, or as I have over here, given you mu and asking for amplitude. Got it, yeah?
Yes, sir.
Yes, sir.
Tell me, when will this system be highest on susceptibility? When will this system be highest on susceptibility? Susceptibility of breaking from each other. M1 slipping over M2. When will that inclination be at the highest, at its peak?
So when they're left from one of the extremes.
When they are left from one of the extreme, or we can say when they are at one of the extreme, correct?
Yes, sir. Yeah.
Yes, sir.
Yeah.
When they are at one of the extreme, right, Krish?
Yes, sir. Yes, sir.
So if they are at one of the extremes, I am on the block M2, correct? We are on the block M2. So we are in which frame? Inertial, non-inertial?
So non-inertial.
Non-inertial. And in which direction is the acceleration? Left or right?
Sir, left.
Left.
The system has moved to its extreme right. So in which direction was the acceleration through and through as the spring was extending? Left or right?
In that case, it was to the right.
Yeah.
Think about it, dear. Cannot go wrong on it. Cannot go wrong on it. I am moving to the right, no doubt about it. But I have told you, and categorically so I have, that acceleration is the immediate
left.
effect of force.
Yeah, left. Yes, sir.
The
Yeah,
left.
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 Which
Left.
direction will be acceleration? Tell me, left or right?
The
I
left.
am
Left.
moving right.
The
Yes,
left.
Yeah,
Left.
yes, left.
The
It will
left.
be left. Please be careful, Krish. It will be
Yes,
left, correct? Yeah.
Yes,
So
sir.
the acceleration is to the left, and I am to write or draw FBD for M1. Got it?
Yes, sir.
Free body diagram for M1. So normal will act in the upward direction. Good enough. M1G will act in the downward direction. I'm good with that as well. What about pseudo force? As I'm doing from M2, M2 is non-inertial. So pseudo force I'll have to apply on M1. And in which direction it should be applied?
The right.
So right.
Good. So pseudo force will be applied to the right. And what will this be equal to? Mass into acceleration. Now look at this. Look at the bracketed term. Mass into acceleration. Instead of acceleration, I wrote omega square A. From where? From where? A is equal to minus of omega square x. Correct? Yeah.
Okay, yeah. Yes,
Yes,
sir.
sir.
X is equal to amplitude. What will be acceleration? Minus of omega square A. Correct?
Yes,
Yes.
sir.
Minus we have already taken in account. You know that, right? Yeah.
Yeah, yes, sir.
So acceleration being marked over here as omega square A. Got it?
Yes, sir.
Okay. And this block should not move as seen by me. I am on M2, correct? There should not be any relative motion between them, correct? Yeah.
Yes, sir.
sir.
So which force can arrest pseudo force? Of course, force
Friction.
of friction.
Friction.
Right? Yeah.
Yes, sir.
So force of friction should be equal to m omega square. Correct?
Yes, sir.
Yes, sir.
M omega square A should be less than or equal to mu into mg. Remember, Fs is always less than Fs max,
Yes, sir.
or it can be equal as well, right? Yeah.
Yes, sir.
Yes,
So
sir.
from here you get A. What is A from here? Mu G by omega square. Correct, yeah?
Yes, sir.
So we get A should be less than or equal to mu G by omega square. You may ask, but what is omega? I have told you on omega already there. For spring mass system, it is
Omega.
K by mass. Over here they are moving as 1 unit. So M1 plus M2, correct?
Yes, sir.
Yes, sir.
They are moving as 1 unit. Say yes or no?
Yes, sir. Yes,
Yes,
sir.
sir.
So mass will be written as M1 plus M2. Got it, yeah?
Yes,
Yes,
sir.
sir.
Okay. One more question to end the class today. Write down. A block of mass capital M. A block of mass capital M was executing simple harmonic motion. Was executing simple harmonic motion with an amplitude A. Was executing simple harmonic motion with an amplitude A. When crossing mean position, another block of mass small m, was gently placed on it. Another block of mass small m was gently placed on it. If the blocks are to move as 1 unit, if the blocks are to move as 1 unit, find equation for changed amplitude. Find equation for changed amplitude. Now see, it is not our lookout that how did this mass small m not move on capital M. Is it okay? I am placing it gently, and because of adhesive or high friction, there is no slipping. Find, yeah.
But then, is there a spring in this case?
Yeah, there is spring constant K.
Okay, yes, sir.
Capital M was executing its motion, right? Yeah.
Yes, sir.
Capital M moving from one extreme to the other extreme. When it came to mean position, let us say this is the mean position. Then you drop small m, and it continues to move. Got it?
Yes, sir.
So what being asked, certainly amplitude will change. Being asked what will be the change amplitude. How will you go about this one? What will be the change?
Sir,
Yes.
do we use something similar to the previous question?
What is that?
So, like, we can find out the initial amplitude. Uh, yeah, we can find out the initial
Initial
amplitude with
amplitude is
M1.
given to you. See, initial amplitude given to you. Initial omega also given to you. What will that be? Capital K by M under root, right there.
Yes, sir. And then final amplitude will be less than mu g by omega square. Where
But mu
omega.
is not given to you, Krish. There is no information on mu.
Yeah.
There is no information on mu. So here what we can make good of? When you drop, what is speed with which this mass will be moving? Now for speed, I bring to you this equation. Omega square under root a square minus x square, right? Yeah?
Yes, sir.
Yes,
So
sir.
when it is at mean position, right? Mean position means x is equal to 0, right?
Yes, sir.
So V is equal to V square. V square is equal to what to us? Wait a minute. V omega. V square is what to us? Or V is what to us? Omega under root of A square minus 0 square. Right? Yeah, check it out.
Yes, sir.
So what will that be? That will be omega into A.
Yes, sir.
Yes,
So when
sir.
it's at mean position, when you are about to drop small m, it is moving with this speed. And with what momentum? With what momentum? M omega A. Agreed?
Yes, sir.
Yes, sir.
Is the spring force impulsive in nature or it is non-impulsive? Spring force is conservative, and generally conservative forces are
Not
non-impulsive. Remember,
Non-impulsive.
right? So spring is non-impulsive. Therefore, can I say? Can I? I'm asking. Think about it. Can we say that momentum just before drop and just after will remain the same?
Yeah.
Oh,
Yes,
yes.
sir.
Momentum of the system just before dropping and just
Moment.
after will remain the same. You may say friction. I'll say friction is internal. For small m and capital M system, friction is internal, right? Yeah.
Yes,
Yes,
sir. So
sir.
for moment, yes.
So if I take small m and capital M as one system, then this is the momentum in x direction. This is the momentum in x direction before of small m drop, because small m was anyway held. So there was no momentum to be associated with it, right? Yeah.
Yes,
So small m and capital M collectively, what is the momentum? This just before of small m touching. Just before small m being placed atop capital M, what was momentum of system? System comprising of small m and capital M. What was it? Can I say this?
yeah. Yes, sir.
Yes, sir.
And just after capital M plus small
Plus
m
small m.
into V. Now what will that V be? That VV will be omega prime and A prime. Both are to change.
Oh, yeah. Yes, sir.
Yeah. Yes, sir.
Okay? Because omega is K by capital M. What will be omega prime? K by capital M plus small m. Getting it?
Small m.
Yeah.
Yes,
Yes,
sir.
sir.
Now you can equate and get. Correct?
Yes, sir.
Okay, dear.
Yes, sir.
Yeah. Yes,
So
sir.
we saw questions on translational motion today. We are to get to fluid and other part as well in the time to come. Anything to ask, anyone?
So I have a doubt in electrostatics.
Yeah, ask.
Sir, it's Euro. So 17th
Uh,
question. So
did it?
I'll read. Suppose the surface charge density over a sphere of radius r depends on polar angle theta, as sigma is equal to sigma naught cos theta, where sigma
Uh-huh.
naught is positive constant. Show
Yeah.
that such a charge distribution can be represented as a result of small relative shift of two uniformly charged balls of radius r whose charges are equal in magnitude and opposite in sign.
We did that,
Sir,
dear, this one. We forgot. We
no
did
sir.
now rho L minus rho. And then we got the final answer as rho L cos theta. Do you remember?
Yes, I remember that, but then I don't understand the question. So two
Question is
balls.
this one. They are saying that there is a sphere. Polar angle, don't get confused. This is the angle that they are talking about. Okay. A
Yes, sir.
sphere on which sigma is varying as sigma naught into cos theta. Alright, yeah.
Yes, sir.
This side will be positive, and the positive will get sparse as you are moving to the pole, and then you will get negative. This will be negative dense, and then here, correct?
Yes, sir.
This is how it will vary. Now they are saying that prove that you get this when you take two spheres and bring them very close to each other.
So that's what you solved that day, roll cos theta. So
Yes. And we got it as rho L cos theta.
theta.
And rho
Yes, sir.
L cos theta as rho multiplied with L can be written as sigma. Because this is charge per unit volume multiplied with length will get you charge per unit area, correct?
Yes, sir.
That day we were searching for the number, by the way. You got the number today, isn't it?
17. Yes, sir.
Okay. Okay then.
Yes, sir.
Keep solving questions
Yes,
there,
sir.
all of you. Goes to all,
Yes.
right?
Yes,
Thank
Yes,
sir.
sir.
you.
So this Sunday or we have AITS, sir, in Akash.
Sunday.
It's not
Sunday.
Sunday.
Sunday anyway, I'm
Sunday.
not keeping your classes. I'm not keeping this batch class on Sunday.
No,
I
sir.
keep
Sunday
the other
we have.
batch class, foundation and the other guy class.
No, sir. Sunday we have a term test, and on 10th we have AITS.
Oh. 10th is which day?
The 10th. I'll send you the timetable, sir. I'm not sure of the day.
So AITS will not be held through the day, right?
No, sir. No, sir. The only that's one advanced one, sir. That's what.
Advanced one. Advanced will come after of mains, no?
Yes, sir. Yes,
What are
sir.
the portions here? Krish will be performed here. What are the portions?
The portions is electrostatics and electric potential. The first two chapters in Akash. So basically that one. Till capacitors. Then
Done
in
everything?
sir, I'm doing electrostatics right now. I started with Eurodov right now. So now I have to start with potential. So because I tried mains in Akash, so set A. So I did not get in many of the questions. So because I thought I got confused. Then I attempted advanced. So advanced I got all of them.
Okay,
So
good.
I got all of them in advanced.
Okay, good. I'll be looking forward for advanced examination only, but mains is also to some extent the substantiation. Okay. So
Yes, sir.
keep to time because generally that is the point when students go slightly haywire. So please arrest any confusion on timing. Make
Yes,
a
sir.
management which you are to adhere to. It should not be that okay, good on papers, but when it comes to examination, it gets flouted. That should not be the case. Okay?
Yes, sir.
Okay, fine. Fine,
Yes, sir.
I'll be just opposing it, don't worry. Fine. Thank you.
Thank
I'll
you,
send
sir.
you, sir. Thank you, sir.
Thank you, sir.
Thank you, Tian.
Sir, can you send